Hassler here. Today in class, to start the lesson for 3-7, we actually used Desmos. We explored with the Shira the Sheep activity. And so if you go to Classroom, Shira the Sheep Desmos is posted under the 3-7 lesson, and check your understanding for today. But instead of going through that with you, I'm going to let you go through that and play with that on your own. And I'm going to do the check your understanding with you. The ideas on the check your understanding is similar to the ideas with Shira the Sheep. But with Shira the Sheep, you actually get to play around so that the sheep either gets to eat grass or falls into the water. And I want you to be able to have that experience. And so in the check your understanding, we're just going to go through and do these 6 problems here. Problem number 1 says graph the inequality x is greater than or equal to -4. And so one of the things that we had talked about in class was that when I have something like greater than or equal to, I'm going to have when I have a greater than or equal to, I'm going to have a closed circle. That closed circle is because the equal sign tells me I'm including it. And greater than means that I'm going to graph numbers that are bigger than my solution. So I'm going to graph numbers to the right. So when this says x is greater than or equal to -4, I'm going to put a solid dot on the -4, closed circle because it's equal. And then I'm going to graph numbers that are bigger than -4. So like -3, -2, -1, 0. All these numbers to the right of -4 are bigger than -4. So I'm just going to draw a big giant arrow covering that part of the number line. And then it says, then write it in a different way. So I'm going to write this inequality in a different way. And so instead of saying numbers that are greater than or equal to -4, I could write that -4 is smaller than or equal to all the other numbers. And so if we're not sure about this, we can always use a test value to see if the statement holds true in both inequalities. And the test value I like to use is 0. I like to use 0. So what happens if x is 0? Okay, well up here, if x is 0, then that means that instead of writing 0, I'm going to write 0 is greater than or equal to -4. And that is true. That is true. And notice that 0 is graphed in the solution that is shaded in blue. 0 is a number bigger than -4. It's part of my solution. Down here, though, to test if I wrote this the correct way, I could say -4 is less than or equal to 0. And that is also true. -4 is less than 0. And again, that means that this inequality here is equivalent to this initial inequality here. Notice that everything has changed position. The 4 is now on the left. My inequality symbol has flipped, and the x is now on the right. That inequality symbol is opened to the x initially, and that inequality symbol is still opened up towards the x. We talked about this in class for lesson 3-6, but it's, again, just emphasizing that idea in this check your understanding. All right, question number 2. Question number 2 says solve the inequality and graph the solution. And so just like with equations, you can draw the line down. It's not really through the equal bar because I have a less than symbol, but that way I can keep this balance, right? I'm going to subtract 7 on both sides. So I get 2x is less than -12, and I can divide both sides by 2, and so I get that x is less than -6. Now, a less than symbol means that I'm going to have an open circle because there's no equal bar, and I'm going to draw an arrow to the left because I'm going to graph numbers that are smaller than -6. So let's go ahead and put an open circle on the -6. There's no equal bar, and so it's an open circle. And I need to graph numbers that are smaller than -6. So -7, -8, -9, -10. All these numbers to the left are smaller than -6. I'm going to draw an arrow that direction. I could test an answer, right? I had said in problem 1, I like to test x is 0 to make sure that I graphed correctly, right? So here, if I say that x is less than -6, well, that's not true. And so I shouldn't graph the part that has a 0. That part should not be graphed because that does not make a true statement. All right, in number 3, it says solve the inequality and graph it. And so again, I'm going to draw my line here. Trying to get the x by itself. So I'm going to get rid of this 9. I'm going to subtract 9 on both sides. 9 is, now see, I started doing the equal to bar because that's what we're used to. I need to do the less than symbol. I'm going to keep that symbol going all the way down, less than 3x. And then I'm going to divide both sides by 3 to get that x by itself. So 3 is less than x. And then the question becomes, well, how am I going to graph this solution, right? And so, again, I'm going to have an open circle because there's no equal to sign. So open circle, there's no equal to sign on the 3. And it says that 3 is smaller than all of the other values. And so again, if you're not sure how to draw this, 1, you could test a value. What if x is 0? So is 3 less than 0? Nope. So I don't want to graph the section with 0. I want to graph the other section. I could test a value. What if x is 10? So is 3 less than 10? Yes. Okay, so I'm going to graph the side that has the 10 in it. Or I could rewrite this so that instead of saying 3 is less than x, I could rewrite this so that x is greater than 3. And then my test symbols still hold true. 0 is not greater than 3, but 10 is greater than 3. Some people like to graph this instead of the 3 is less than x, so just giving you some options. All right, let's do number 4. Solve the inequality and graph it. So there are a couple ways to do this. We talked in class that I could distribute. This gives me a negative 12x plus 22 greater than or equal to 10. Subtract 22, so negative 12x is greater than or equal to negative 12. Divide by negative 12, and one of the things that we talked about in class is that when I divide by this negative number, in order to maintain equality, my inequality symbol has to flip. Now again, you know I like to test these values, and so if I test x is 0, 0 is less than or equal to 1, that's true. So if I were to graph this, I would have, and I'm going to graph it below because I'm out of room. Close circle on 1, all the values that are less than or equal to 1. But I should really go back, especially in this case where I'm claiming that we flip this inequality. I should go back and test the original. Like what happens if I put 0 in here, right? Then if I put 0 in here, I get 0 plus 11 greater than or equal to 10. And so negative 2 times 11. Negative 2 times 11 is negative 22. Well, that's not greater than or equal to 10. So in order to have a statement that is true, when I divide by this negative, when I multiply both sides by negative 1, then I have to flip the symbol in order to make this true. And that's one of the things that we talked about in this year, the sheep problem, that in order to maintain this true statement, I have to flip that inequality symbol when I divide or multiply by a negative. So that's one of the things we'll be talking about today or the next few days. All right, let's talk about problem number 5. It says consider the inequality 1/2 x plus 9 is less than 0. Test the different values given below and circle which ones make the inequality true. That just means that I'm going to substitute negative 22 in plus 9. Is that less than 0? Well, negative 22 plus 9 is negative 2. Yep, that's less than 0, so I'm circling that. And I'm just going to go through and test each of these. And so this gives me negative 10 plus 9, which is negative 1. Yep, that's less than 0. I'm going to test this next one. Half times negative 18 plus 9. So this is interesting because this gives me negative 9 plus 9, which is 0. But is 0 less than 0? And the answer is no. 0 is not less than 0. 0 is equal to 0. If this said 0 is less than or equal to 0, then it would be true. But it doesn't say that. It says 0 is just less than 0, and that's false, which means anything beyond this is going to test so that it's false, right? Let's just check it. If I have 1/2 times 0 plus 9, I get that 9 is less than 0, and that's not true. And if I put 9 in there, I get a number even bigger, so that's not true. So then it says decide all the values of x that make the inequality true. Well, it kind of looks like we cut off at 0. Or I'm sorry, at -18. When I substituted -18, it kind of looks like that didn't work, but everything else below it did. So I can verify this by solving. I can subtract 9 on both sides. I get 1/2 x is less than -9. And if I multiply both sides by 2, I'm not flipping the inequality because I multiplied by this positive 2. You get x is less than 18, not equal to, because when I put -18, I got 0 is not less than 0, so not equal to, but anything less than -18 would work. All right, Luella has $15 in her pocket and is going ice skating. The cost of renting skates is $4, and the cost per hour of skating is $2.50. Write an inequality to describe the number of hours each that Luella can spend ice skating. Okay, so she has 15 to start. It's $2.50 per hour to skate. But I only have $15 in my pocket, so I could spend 15. I could spend less than 15. I cannot spend more than that. Oh boy, I set this up wrong. Let me start over. My apologies. All right, restart. I have $15 in my pocket. That's the most I can spend. All right, renting skates is $4 plus $2.50 per hour to skate. And that amount of money could be less than 15. I can spend less than 15, or I could spend equal to 15. Some friends in class said, well, 15 is the most I can spend. So 15 is the most I can spend. So I could say 15 is greater than the amount that I can spend. And they wrote the inequality this way. And those two things are equivalent. Notice that my inequality symbol is opened up towards the 15 in both scenarios. I could test values like 0. I could put 0 in for h. And in both cases, I would still have true statements. So you can set it up either way. Can Luella ice skate for 3 hours? So I'll just use the screen. Well, let's check. If I substitute the 3 in, I'm going to get 4 plus $2.50 times 3, which is $11.50. Yes. Because $11.50 is less than 15, and she has 15 to spend. What's the maximum number of hours that she can spend, that she can ice skate? So I'm just going to go ahead and solve this inequality, right? I'm going to subtract 4 on both sides. I get 250h less than or equal to 11. Divide by 250. So h is less than or equal to 4.4. So I could skate for 4 hours. I could not skate for 5 hours because 5 is not less than 4.4. So the most I can skate is 4 hours. 4 is less than or equal to 4.4. So the maximum number of hours is 4. So sometimes we end up with decimals in our answer, and we have to think about, which side of that decimal makes the most sense, the smaller number or the bigger number on either side of 4.4. And in this case, 4 hours is going to make the most sense. All right, so again, I encourage you to go back and play with Shira the sheep. The homework is to do the 3.7 practice, and whatever questions you have, make sure that you ask.